So for GSOC, we're working on this code and making it more stable, making some improvements. We fixed various bugs, and some of the Chinese chapter. Any of the Chinese guys here? Put your hand up. Okay. Zhang Wei and Cheng Yu are working on this project. We're improving the anti-detection techniques. There's a constant arms race against the bad guys. We're trying to improve our technologies as well. If you want to find out about CBEC, this is the website, you can download it, it's all open source. There's also a white paper on it. But one of the problems with CBEC is, every time the kernel changes, you have to recode your tools. If there's a new module comes out or different kernel capabilities, you've got to rewrite your software. So it's quite easy to detect as well. So we're playing this constant game of cat and mouse with the attacker, trying to make our tools better and harder to detect. And the obvious evolution is to go from the OS and the host to the hypervisor layer. So we want to be able to install OS into a virtual machine and use a hypervisor to capture the I/O covertly from the attacker. So we started looking at the VMsafe API, which is a closed source API. We couldn't really do that. So we looked instead at a simple emulator, which is QEMU. We took QEMU and extended it so we can capture the I/O of a virtual machine and extract the data from it. This was a project, Sheng Yu, if you're still here. Oh, he's over here. This is a GSOC project, Chinese chapter. And this is our first attempt to build a hypervisor Trojan, where we can take data out of the honeypot covertly. It's still an ongoing process. If you're interested in finding more about the QEMU CBEC, which is Quebec, it's on the CBEC website. There's a URL for it. And we released the Know Your Tools white paper, which describes more about the technologies behind virtual machine introspection. This is the KYT Quebec paper. And it explains some of the reasons why we need these tools. The authors are the Chinese guys here and also Brian at the back. So if you're interested in hypervisor honeypots, these are the guys to talk to. And it explains how it uses introspection and a series of breakpoints to do analysis. Talks you through the process of installing Quebec. And then gives you some examples. In this example, you've got a virtual machine running Windows XP, so it's back 2. Somebody's typing in the virtual machine. All the keystrokes have been exported from the VM to the command line for use in the honeypot. So that was server-side honeypots. You can see we're still active both for low interaction and high interaction. Now we have client-side honeypots. These aren't static systems. They have to go out to the internet and look for attacks against your systems. We analyze the behavior of the web page. We see whether or not the web page causes a state change in the honeypot. If it does, we say it's malicious or potentially malicious. So our high interaction tool is called Capture HPC. It's been developed over the last few years, initially by Christian. He's still here. No, he's not. He's outside. And some of the guys in New Zealand. So Capture is a full Windows OS running in a VM. You drive the web browser, i.e. normally, to a website using a Java server. It instructs the browser to go to the website. It looks for state changes in the virtual machine, so file system modification, process table or registry changes, and then it categorizes the behavior of the website based on these changes. It also extracts PCAP files, downloaded binaries as well. And it's not just for IE, you can use Firefox, different browsers. You can also support media files or PDF documents or Office documents. So as part of the GSOC work, we've been working on trying to scale the performance of Capture, so building architectures for deploying client honeypots, having layers of proxies or nested low interaction and high interaction honeypots. The idea there is if you send a request to a system that looks suspicious using a low interaction honeypot, you then go back with a high interaction honeypot and do further analysis. If you're interested in Capture, it's been developed for the last few years. This is the website. And we're using tools like Capture in our research as well. So we'll go out to a list of websites, we'll crawl them all, we'll break them down into categories such as news sites, sports sites, adult sites. We'll look for the percentage chance of being compromised on these sites. We'll publish various papers on our white paper section about malicious websites. And this is the kind of technique that's being used today by WebSense, by Google, to crawl the internet on a much larger scale.
Hey Dave, you might want to point out SurfNet and the Polish guys, explain how they're using it.
Yeah, okay. So one of the ways Capture has been extended is there's a European project called the Honey Spider Network, which is using Capture as the basic engine and providing a system, a service for certs to scan their community websites. So Polish guys, you want to raise your hand? These guys are here. If you want to ask them questions about using Capture, they've got plenty of experience using Capture.
Is Surf here? SurfNet, is Roger here?
Not yet.
Not yet.
Not yet? So the guts are a little slow?
So one of the problems with high-crashing honeypots is scalability. Using a real VM, a real computer, going out to the web and surfing many thousands of websites is quite cost-intensive. It takes a long period of time. So we tried to improve our performance. We developed visitation schemes. These are different ways of connecting the browser to many websites and narrowing down on malicious behavior. We'll publish some figures on what we think is achievable per VM. We can get into sort of tens of thousands of URLs per day per virtual machine. But eventually you start to run out of problems, even with fast imaging, lots of virtual machines. So you need to look at a low interaction client honeypots. These are emulated systems. It's not a full browser. It scales much more linearly. You can send many, many thousands of connections from a low interaction honeypot. So our Python honey client, PhoneEC, is our first attempt to build a low interaction honey client. It's written in Python. It should be safer because you're running Python on a Unix machine pretending to be IE. You're emulating the service. Because it's an emulation, it's quite trivial initially at least to detect it. It doesn't have many of the complex features of a browser. So if you're an attacker, you can try and detect it and easily bypass it. So the purpose of GSOC was to try and extend the DOM emulation to make it more like a real browser and do better emulation. This has been worked on by some Chinese students from the University of Peking who aren't here today. Uses the Mozilla SpiderMonkey engine, has a Python wrapper called Honey.js that wraps around it, lets you make calls to it. You can easily change the personality, because if you want to crawl a website using lots of different browser versions, it's just a simple config change. So you're not having to create lots of virtual machine images. You can very quickly check with different browsers.
You may want to point out Angelo so people, if they have questions.
Yeah, okay.
So
it's written in Python. You can write your own vulnerability modules in Python. It also has mock ActiveX controls, so we can stub out or emulate ActiveX functions. One of the neat features we added in GSOC was using a libinu to detect shellcode in the JavaScript bytecode. This is inspired by the work on Nepenthes and Dioneia. This is a generic way of detecting shellcode within a low interaction client honeypot. It also can handle Office documents and PDFs. You can embed JavaScript or VB in PDFs. For instance, you can take that and read it from the PDF. And then lastly, output changes, making it more easy to work with using XML and more structured content as well. This is still a work in progress. Andrew is in the room somewhere.
Yeah.
Yeah, okay. Andrew at the back is the lead developer on PhoneEC, also Jose Nazario. If you've got any questions about client honeypots, Andrew is your man. You can get PhoneEC from the website on Google here. So that was server-side honeypots and client-side honeypots. We also see a lot of web attacks. So we developed a web honeypot called Grasstop. Here's Lucas in Germany here. Okay, so Lucas at the back is a developer of this. It's a GSOC project. This is a lightweight, minimalist web server written in Python. It looks at the incoming HTTP request. It looks for common web vulnerabilities, things like RFI and MoFi includes, SQL injection. And then it uses a mixture of signatures and also dynamic techniques to try and detect new attacks. It downloads the payload, it stores the attack, and it also does things like tracking the search term used to find the honeypot. People using Google are searching for certain strings, vulnerabilities, versions. It detects those, and it tries to make itself vulnerable to additional services that have similar strings. There's also a plugin to work with SurfNet, which is a Dutch research network funded project. This is the website for Grasstop. It's all public open source. We released a paper on Grasstop at the end of last year. It explains more about it. It's KYT Grasstop. It explains the background to technology, why we need it. It talks about the way the process operated, the attack, the vulnerability for analysis. It shows different methods we can use to emulate web attacks. If you're interested in web attacks, it's worth a look at this too. It also provides a user interface where you can see the stats and the attacks against your web honeypot. So the common search terms, the common countries, who's looking for your honeypot. If you want to extend the honeypot, there's a plugin system where you can write your own vulnerability modules. That's explained with examples of how to write a vulnerability. And it talks about the emulation. So it's capable of emulating vulnerabilities by looking at incoming attacks and changing its behavior against that. It explains how that works as well. So that was Grasstop. We've also got some kind of hybrid honeypots where we've been looking at the network layer. So things like a decision engine that looks at incoming attacks called Honeybrid. It looks looks at the network traffic coming in. It decides whether the traffic should go to a high interaction honeypot or a low interaction honeypot. If it goes to the low interaction honeypot and it sees indications of malicious activity, it uses TCP replay to replay the session dynamically to a high interaction honeypot. So the idea is, if you think some traffic is suspicious, you repurpose it and put it back to the high interaction honeypot for better analysis. This is Honeybridge. And then Nebula is a network intrusion detection signature generator written by Tillman at the back. Tillman, raise your hand. So the idea here is you have a honeypot, such as Argos or Nebula. You run the Nebula daemon next to it. And when the honeypot sees an attack, the honeypot sends the attack trace to Nebula. Nebula looks at the attack and attempts to cluster its information. It extracts some common substrings and tries to build an IDS signature pattern dynamically within 1 or 2 seconds.